Recorded. Okay. From our previous class, we have seen what is ACL and what are the different types of ACL, like standard ACL and external ACL. We have seen taking labs on how do we configure a standard ACL to block a specific destination with help of the IP address. And also we have seen a lab on doing external ACL and blocking a website and allowing the specific ping or allowing the SSH connections. So any questions from our previous lab, guys?
Not really affecting my performance that much yet. They're wondering through like it's nothing. But you know what? We can do better than this. I want to try and crash the game. I want to see what's possible, what the limits are. So let's do 5,000. I was lagged a bit. Has that crashed it? Oh. No. Oh, that's almost filled the entire room. Oh, they started stacking up here as well. Check this out too.
Okay, I'll take it as a no. Okay, we'll start. We'll start working on the next topic, guys, which is wireless fundamentals. So we are at the last 2 or 3, mostly 3 classes or 4 classes, guys. Let me double check. So we have wireless fundamentals, we have network fundamentals, and we have network automation fundamentals. That will be broken into 2 parts, and then we have SD-WAN. So total 4 classes, guys. So I think this Friday will be our last class. Tuesday, Wednesday, Thursday, Friday. Yeah, I think this Friday will be our last class, guys. So if you are someone who is who didn't completed the class test, please do the test too and submit by end of tomorrow. Okay. Thank you. We'll start the wireless fundamentals. So wireless is little different than the data, guys. So wireless is like connecting to the network without having any wired connection, right? So what? Let's take a small example of a home Wi-Fi, like we all know. So there will be a access point that is installed or a router that is installed on your let's say Spectrum company. So you will pay something like $50 per month to them. They come to your house and they'll put a router, and or you will see something like a modem. The modem will be connected to the power socket, and that modem will be connected to a router, and this router will be acting as the access point as well, which is generating the signals throughout your house with antenna, right? So this router will have antennas and it will be sending the signals outside, and you with your phone or your laptop or your PC, you will be getting this wireless signal, and we will be naming the signals as the SSID, which is nothing but the name of the Wi-Fi that you configure. So you will put the username and password that for the security purposes, you will connect to this router with the Wi-Fi signal. By catching that Wi-Fi signal on your laptop, your laptop will have a receiver. That receiver will be catching the signal coming from the router, and you will be getting the Wi-Fi. Okay, so very simple, guys. So wireless access point is generating the signals, and your laptops and your phones having the receiver antennas or the collectors where it can catch that specific signal and it can get the Wi-Fi. And again, after reaching the router, it is all wired connection. It goes to the internet. Like we all know, if you have a switch or a router, the routing table, switching network, that is all same from here. But your local network is all Wi-Fi. That is without any wired connection. So that is nothing but the WLAN. So LAN is local area network and WLAN is wireless local area network. You guys, you all know what is LAN, right? LAN is nothing but devices connecting in the same location is called LAN. So with the wireless, you are connecting devices without any wired connection. You will be using the wireless signals to connect the devices. That is the wireless. Okay. So now let's see how this access point works. Okay. So how does this access point send the signals? Let's see the access point working criteria. Okay, how does it work? So let's say you have a router, which is also acting as the access point. There will be antenna in the router. So this will be antenna. That's this antenna. This one is sending the signals in all directions. From the antenna, this is sending the signals in all directions. Okay. So here, your laptop is acting as a receiver by catching this signal that is coming. So let's say this router is sending the, think about like a analogy like a laser light. So you have a small laser light in your hand. That laser light is sending the beam, right? In the beam, it will send the signal. Similarly, your antenna is like a laser light that is sending the signal throughout the room. Okay, so that will be sending the signal throughout the room. Your devices, okay, that are inside that room, they should be capable of getting that signal. Meaning, like, let's say the signal started with the signal strength of this one. It slowly drops. That is why if your router is in your house, if you go outside of your house, the Wi-Fi signal will be lost because it cannot go for longer distances. There is certain range for your signal, so it will slowly reduce the strength of the signal, right? That's why if your antenna is in your bedroom, if you go to the patio or your balcony area, you may not receive the signal because the signal strength will be lower and lower and it will die, right? So there are two types of wireless ranges that your antenna will be doing. I mean, two types of frequency signals that your antennas will be doing. One is 2.4 gigahertz and 5 gigahertz. So this is the signal strength. Signal frequency at which the signal is sending in the air. I mean, if you remember in India, there will be these FM channels, right? Like 108.3 FM. Like this is nothing but the frequency number. So this radio channel is sending the signals over the air on 108.3 megahertz, right? Like 98.3 something. There are different channels that they send the signals on, right? So what you will do, you will have a receiver. You will tune your receiver in that signal strength, in that signal, in that frequency, so that this signal will be catched by your receiver at that specific frequency. So you are tuning your receiver to listen on that specific frequency. Similarly, wireless works on 2.4 gigahertz and 5 gigahertz. That's where the antenna is sending the signal. Okay. So let's say so the 2.4 gigahertz is going for the long distance. It can go little longer. Like if your antenna is there, if your antenna is here, if this is your antenna, if it is generating the signal like this, it can go longer. Okay, whereas the 5 GHz, it can do only shorter distance. It cannot go longer like 2.4, but the speed of the signal is smaller or lower. Lower speed of the signal. Here, short distance, but faster speed. Okay, so the reason because of the low speed is because it can go like long distance. If someone is sitting here, this signal will have the less strength because the strength keep on reducing. Okay, but because 5 GHz like only go for till here distance, it can go much faster till here. So the rate at which the signal go will be very faster compared to the longer distance. So think about like you throwing a ball. If you go for long distance, the velocity will get lower and lower by the end, right? But if you're going for a short distance, the speed will be very high. That thing same applies for the 2.4 versus 5 GHz. It can go only short distance, but it can go with the faster speed. It can go long distance, but with the lower speed of the signal. That's how the signal transmission will take place on the 2.4 versus 5 GHz. And also we have to understand about the channels. So let's say you are in a house. Yeah, there are multiple users, right? So multiple users will be using the same Wi-Fi. It's not like only one person is using all the Wi-Fi. Multiple devices like your laptop, your phone, printers, they all use Wi-Fi, right? So there should be non-overlapping channels so that every person will be using his dedicated channel space. Let's say 2.4, right? So 2.4. Let's say there is the antenna here. This one is sending the signal. This is signal 1. And similarly, it is sending signal 2. Signal 3. Signal 4. So it keeps on sending the signal. But there are places where this signal and the other signal will not overlap. For example, if antenna is keep sending the signal, think about like there is a person standing here and he did a rope and he is doing the rope like this. Like he's fluctuating the rope, just like he's shoveling the rope like this in this fashion. So he keep on sending the rope, second rope, third rope, but there should be a place where it will perfectly isolate. The first signal will not overlap with the second signal. The third signal will not overlap with the fourth signal. So there are different ranges where the first signal will not overlap with the second signal, and that channel is called non-overlapping channel. Because if the signal 1 is going, the signal 2 may overlap with signal 1, which is not a good signal. But maybe signal 6 will be going in this way that it will not overlap with any other channel. So there is a frequency at which the signal will be sending, and there will be non-overlapping channels. Those are called 1, 6, 11 channels. So I want to reiterate. So let's say you have a signal. This is the first signal. And there is a second signal. Let's change the color. So this signal is overlapping with this signal. So it is keep on doing the same. But for example, there is a sixth signal which is starting like perfectly like this, which is non-overlapping with any of the channels. So then users can use first signal and the sixth signal and similarly the 11th signal. So there is a difference of 5 channels between them. 6 minus 1 is 5 and 11 minus 6 is 5. So for every 5 frequencies, this channels will not overlap. In that channels, usually you will be connecting, like your laptop will be connecting on 1, your PC will be connecting on 6 channel, your printer will be connecting on 11 channels. So that is how the non-overlapping channels will be, where the different users will be connecting without overlapping with the other users in the network. So in because 2.4 is less speeds, so you have only 3 non-overlapping channels. But in 5 GHz there are like a lot of speeds. It goes with a lot of speed channels, so there will be 24 non-overlapping channels in 5 GHz. So it can accommodate more number of users in 5 GHz channel. In 2.4 GHz, you can have only less number of users, but it can go with a longer speeds. I mean, longer distance in 2.4. Whereas the 5 GHz will have more number of channels, 24 non-overlapping channels, but it can go with the faster speeds, but lower distances. Am I making sense, guys?
Yes, sir.
Yes, sir.
Okay. So that is about the frequency over non-overlapping channels, all that stuff. But now let's see how does this architecture looks like in the in a small you already have seen a small home, right? That home is called autonomous access point, meaning there is only one access point which is on the router that you are manually managing that without having any controller. Let's say you have an office now, okay, or let's say a small building, okay. Let's say you have a small building. Inside the building you have access point 1, access point 2, access point 3, access point 4, access point 5, right? So these access points, let's say you are trying to have a switch and this switch is configured with all these access points. So instead of you logging into each access point and configure SSID, SSID is nothing but the Wi-Fi username and password, guys. You will configure a SSID where you will name that specific SSID and you will define a password for it, right? Where you will connect. So instead of you manually managing it, you will have a controller. And with the controller, you are managing all of the access points from this configuration part. So you will configure it here and you will push the configuration to the all the devices. You are creating a centralized device. With that device, you are managing all the access points. That is the concept of lightweight access point. Lightweight means there is no configuration on the access point. You have a controller, and the controller is managing all of your access points, and that is where the management works. Okay. So how does this actually work? So this works on the configuration of a tunnel. So let's say let's pick an architecture. How does it really work? Okay. So let's pick an architecture. How does this work? So now I took a building. Inside that building, I take a floor. Okay. So I took a layer 3 switch. Okay. Let's pick layer 2 switch, because you guys know already a router on a stick model, right? Let's take a router on a stick model. So there is a router, and this router will be connected to a switch, and this switch will be connected to the access points: AP1, AP2, AP3, AP4. Okay, and this one is sending the signals. This one is sending the signals. So there are different access points in the building that they are all sending. They are all connected to the switch. Switch will be connected to the router, and this router is connected to the controller. So this access point will make a tunnel to this controller. This access point will make a tunnel to this controller. This access point will make a tunnel to this controller. This access point will make a tunnel to this controller. This tunnel is called cap-wap tunnel. Cap-wap tunnel. So what is a cap-wap tunnel? So we have a centralized controller to manage all of this access points. So that is why it's called control and provisioning of wireless access points. So this access point is forming run to the controller. Similarly this one, and similarly this one. So it is this controller is controlling and provisioning. Provisioning means pushing the configuration to the access points. That is why it's called a cap web tunnel. That is how the access points will be able to get managed by the controller. So this access point, once it's plugged on, once it's powered on, it will try to find the controller, just like DHCP. You guys know what is DHCP. DHCP is looking for the IP address of the server. It will send a discovery message. By discovering the server, it gets an offer message. It will get an request packet. It will send a request, and then it acknowledges and get an IP address. The DORA process. Have you guys remembered a DORA process?
Yes. Yes, sir.
Yes, sir.
Yeah. Similarly, the access point will send the discover message, but this time this is discovering the controller. So that will be done on the DHCP. Actually, DHCP works on the port 67, right? But this one works on the DHCP 43. Sorry, I forgot the port number. So it works on the DHCP 43. So this one will send the discover message on the DHCP 43 in looking for the controller. Okay, so that is how the discovery works, and then it gets acknowledgement and it forms a tunnel. So again, so this is for looking for the controller, but the cap web should also send the configuration, right? This one should send the configuration to the access point, and this access point should work on based on the configuration sent from the controller, because you are managing all the ports from the controller access point. So for that, it has to send the configuration that works on a different port, and that port is called 5246, 5247. This is not mandatory to remember. Just because I'm saying class, I'm just remembering the ports. On the real time, you don't have to remember this kind of theory questions, but certification wise, yes, I mean they might question you on that. But again, it's not a brainer. You can by reading stuff, you can remember those port numbers. So that's where the configuration will be sent on these ports, and the data plane will be working on this port. So that is how the lightweight access points will find the controller, and then it will be getting the configuration. Okay, any questions, guys? So this works good when the access points and the controller are in the similar location, guys. So these access point and controller are in the same location. But what happens when we have multiple locations and multiple access points? Let's say we have a company in multiple locations in US or Europe or Asia Pacific. The access points are spread across the country, right? So then what will happen? So this access points should form a tunnel to the controller. Let's take a different diagram. Okay, let's. So again, you have a router, and this router will be connected to a switch. This switch connected to the access points in that specific location. Similarly, you have a router. This router is connected to the switch. And this switch is connected to the access points. Same thing repeats, but you should have a controller that is managing these access points, and these access points. This is no issue. I mean, these access points will form a tunnel. These access points will also form a tunnel. And these access points will also form a tunnel. But what is the issue, guys? Let's say this location A access point wants to go to the internet. It has to go to all the way to the controller, and the controller will send them back to the internet. So it cannot locally break out. This access point cannot directly go out. Like this router has internet connection. So from location A, let's say this is Chicago, it has to go to all the way to the controller in the Atlanta at the headquarters and then go to the internet. So it's like we are going from Chicago to Atlanta to find the controller, and the controller is redirecting to the internet. So it is making an extra effort to go to the internet. But what if we can have a local breakout, which is called split tunneling, meaning like there will be one tunnel, it will be going to the controller for the configuration part. Once the configuration is done, it should locally break out, directly going to the internet from with the local router and going to the internet directly. So that is called flex connect group. So what does this do? So it will form two tunnels, one with the controller to get the configuration. So once the configuration is done, it will have a split tunneling going to the internet directly without going to the controller. Let's say if I want to go to google.com from this location, I can locally break out and go to the Google directly without going to the controller in the Atlanta. And that is done with the flex connect groups with the split tunneling. So there is another method of configuring the access point with the flex connect with split tunneling of the configuration. Any questions on the topic, guys?
Sir, can the routers act as access points?
Yes, obviously, if your router has an antenna, that can send whichever device can send the signal that can act as access point.
So why can't the routers form the tunnel instead of access points forming individual tunnels?
In this case, router is not the access point.
Okay.
See, your router is a device, one single device, but let's say you have a building with 10 floors. So do you think your router can send the wireless signal to all the 10 floors?
No.
Then obviously you should have access points, right?
Yeah. Okay.
So your router can form a tunnel, but if it's a single router and if it's a small location, I agree, the router will automatically form a tunnel to the controller. But it can solve only one specific small location with specific square feet.
Mm-hmm.
Any other questions?
Sir, is that possible to have multiple controllers?
Yes, it is possible to have. If one primary controller fails, they can be a backup controller, and there is also a concept of anchor controller and foreign controller. Let's talk about that here in a second. But first, let's start talking about primary and secondary controllers. Okay.
Okay, sir.
So there will be controller 1, and there will be controller 2. Just like redundancy, we have redundancy. What we will do, we will have a cluster configuration, HSRP or VRRP like kind of setup. But here in this case, there is a concept of SSO, stateful switchover. So what does this do? This one will be acting as the primary device. If this one go down, this one will keep on sending the heartbeats to the secondary controller. This will take over. Just like your HSRP, VRRP, active and standby, this one will be acting as the active, and this one is passive. If the active go down, with the heartbeats between them, the passive will be taking over. That is a stateful switchover, but it is acting as a active and passive. So this one is always generating the traffic, like forming the tunnels. If this one fails, this one will take over. So that is the active standby setup. Okay. Any questions on that? Okay, now let's start talking about what if there are different controllers to manage different branches. Let's say I'm going to take two buildings. One is the headquarter building. Another one is like remote branch office. So headquarters is in Chicago, just like earlier, and then remote branch office in Atlanta. Okay. So what will happen? Let's say this remote branch office, let's say it has its own controller. Okay. Just like the question that you asked, let's say this one has the controller. Okay, let's say this one also have a controller. Okay. Because we don't want the access point in the guest office, don't want the tunnel to be forming to the controller in the main office, right? So we don't want that. Okay. What we wanted is, we wanted all the access points in that specific location. They should be forming the tunnels to the controller in the local location itself. Okay, that is how our architecture is. Okay, so what happens is, this controller will be forming a tunnel with this controller. Let's change the color. Okay, so here what is happening, if a user is moving, let's say we have a user here. This user is like a corporate user. Let's say he's a manager that lives in the Chicago area. Let's say he got some business work. He came to the remote branch office. So the remote branch office access point, once he logs in, it will check the user computer MAC address. This controller will try to authenticate with this controller with the tunnel IP, and then he will be given access to the company, and then he will locally go outside. So in this kind of model, there will be a tunnel between the headquarters and the remote branch office. So that is called, local and the foreign controller. So this is the local controller and this is foreign controller, and there is a tunnel between them, so that your guests can move between the locations as well without having any issues, because there is a communication between these two controllers with the tunnel in play. But the local users can directly talk to the controller and go outside directly with the local controller itself. It does not go all the way back to the headquarters for the remote connection. Okay, is that clear now?
Yes, sir.
Any questions, guys? One question. 1 second, I have to take this. Yes. Any questions, guys?
No, sir.
Okay, guys, we have gone through a lot of topics, so let's reiterate. So we have seen a small home setup with having a single access point or the router, which is called autonomous access point. We directly manage this device and it will send the signals. There are two kinds of signals, 2.4 gigahertz and 5 gigahertz. 2.4 is for the longer distances, but for the shorter speeds. 5 GHz is for the faster speeds, but shorter distance. 2.4 has the 1, 6, and 11 as the non-overlapping channels. 5 GHz has the 24 non-overlapping channels that it can go. There are extended ranges, guys. So I mean, if you go to extended 5 GHz, you will have more channels. For example, there are different Uni 1, Uni 2, Uni 3, and Uni 4. It ranges from 36, 32, 36, 40, 44, like that. It can go up to 144, and then actually no, 177. It can go up to so 30, 44, 48, 52, 60, 64, 68, like that. And then it starts again from 96, 100, like that it goes. It go till 144, and then again it starts with 149, 153. It goes till 177. So total 24 non-overlapping channels are there, where users can be having the usage of the signal without having any interference between the signals. Okay, there is that. So then we talked about managing multiple access points with a controller. So that can be done with a tunnel called CAPWAP tunnel. Control and provisioning wireless access points. With that tunnel, a single controller can be used to manage all the access points of a centralized location. So access points will be sending the request to join the controller on DHCP option 43, and the controller will join them accordingly, and you can push the configuration with the CAPWAP tunneling with the cap web, data port and the control port. Okay. And then we have seen about flex connect groups. When we have multiple access points in different locations, instead of directly going to the headquarters, we can break out, we can form a split tunneling so that locally the tunnel will be split and the access point will go internet directly from with the local tunnel. That can be done with the flex connect group. Okay. And we talked about HA, high availability, which is nothing but if one primary controller goes down, there is a concept called stateful switchover SSO mode, where both of them act as the primary and secondary. If the primary goes down, secondary will take over with the help of the SSO. And then we have seen about the foreign controller and the local controller or anchor, where there will be tunnel between the anchor and the foreign controller, where they communicate and make sure that when the users roam, they will still have the communication working with the tunnel between them. Okay. And then we need to talk about the wireless security, guys. So in wireless security, there are different security types in the wireless security. So let's start talking about the wireless security. Before I do that, any questions, guys? Is it all clear? Okay, guys. So now, what is wireless security? So let's say you have an access point. And this access point is sending the signal. And we should be having some username and password. Without that, no one should be able to access our signal, right? So that signal, that protection is called wireless security. So we can do it with different types of encryption methods. So the first one is WEP. So WEP is the first form of the security in the wireless, where so in WEP, it is an open authentication. Okay, so there is no authentication, like there is no username and password, but it is secured with the RC4 cipher algorithm. Like let's say there is an access point. The access point is sending the signal, and some intruder catches that signal. He should be able to collect that information, like he should be able to download that signal, and then he can replay that and identify what the user is browsing on the wireless. So that is done with the WEP RC4 algorithm, but it is not that secure because the intruder can capture this data and then they can break that algorithm and they can read what the user is doing on the network. Let's say you have a private network and you are opening a banking website with your Wi-Fi signal. If you are using WEP algorithm, a intruder can capture your signal with Raspberry Pi or any signal collector, and he can read that signal and he can decrypt that signal and he can know the username and password of your bank data, right? So it's not good. It is not at all good. Okay. So they moved to WPA. In WPA, they did a better algorithm, which is TKIP. TKIP algorithm, which is better than the RC4 with better encryption. Okay, so they increase the security with another algorithm with 256 bits. It's like the strength of the key. If you think about like having a longer password with special character, 15 digits password. If it's longer, it is strong password with different combinations, right? Similarly, a WPA will be tough to break. It is in 2003 though. So intruders, okay, they also had an algorithm now. They were able to break it. So in WPA2, they came with WPA2, which is with the AES algorithm. AES algorithm, but with CCMP encryption. Okay, so this is the best one because intruders were able to break TKIP algorithm, TKIP, temporal key integrity protocol algorithm. They're able to break it. So now they did extra security in 2004. They went with AES, which is very tough to break compared to WPA. WPA is very tough. So intruders was not able to break it until 2018. Even in 2018, they did not completely broke it, but there are chances where if a user works for 10 years, 5 to 10 years, they can be able to break AES. So then they came with in 2018, they came with the WPA3, where they still use AES with GCMP algorithm. Okay, which is like Galois counter mode protocol. So it is the latest one. No one will be able to break it because they increase the size of the key in GCMP better than the CCMP. So it was better secure. If someone wants to break it, it might take 50 to 60 years to break this one. More and more secured. So whatever algorithm we are using, so in RC4, it is the weakest algorithm. They went with the TKIP, which is like temporal key integrity protocol algorithm. Which is secure, but they were able to break it easily. Intruders were able to break it. This one as well. Then the AES, which is advanced encryption. Where they went with the CCMP, which is with the better encryption. It is also not as secure as the GCMP. So they went with the GCMP, which is more secure. WPA3 is the most best secure one with 256, 128 bit, 192 bit encryption with better security. So that is how the wireless protection will be done on the real time. So let's say if you're putting a password to your router now, it is using encryption like WPA2 or WPA3. That's where the encryption is done today. No one are using WPA or WEP now. It is out of industry standard. It is an older algorithm. Okay. Any questions on this topic, guys? Okay, let's see. Anirudh, what is the difference between 2.4 and 5 gigahertz?
2.4 gigahertz, like the signal can go very long, but the speed will be less. Whereas in 5 hertz, the signal as compared to 2.4 gigahertz, the signal will go short as compared to it, and it will be very speed.
Okay, thank you. Datta, what is a cap web tunnel?
It is a fine, it's channeled. Sir, can you please repeat the question, sir?
What is a cap web tunnel?
This forms a tunnel from access point to headquarters of centralized controller. Like control
The purpose
and
of-
provisioning wireless access point.
Yeah, it will be used to configure the access points from a centralized controller. So the access points will form a tunnel to the controller. Okay. Bhumika, what is an autonomous AP? Bhavana, what is an autonomous AP?
Sir, it is a controller that allows a single device to manage the traffic independently with any additional support from the base point. Also, it will be having a choice between an autonomous and the non-lightning of APs, which will be having a specific or else like a wireless network we can deploy with.
Yeah, autonomous AP does not need any controller. It can be managed individually. That's where we can push the configuration. It's for a short environment, small environments where it does not have any multiple access points. It can be managed individually.
Yeah.
Madhu, what is a lightweight IP?
It is used in TCP/IP design. The lightweight IP is widely used in open sources like TCP/IP.
No. Where did that come from? Lightweight AP is what the controller is managing it, right? Controller is managing an access point from a centralized place. Every configuration will be done from the controller. So lightweight means we are not making any configuration to the access point itself. We are making the configuration from the controller. That's why it's called lightweight.
Number is 43, right?
43. Oh, yeah.
Yeah. It will be
43 port,
looking for the
port number.
controller with the DHCP option 43. The controller will be pushing the configuration to the access point. That's why it's called lightweight, because we are not making any configuration. Okay. Fanindra, what is WPA2 and what is the algorithm that it uses? Richa, what is WPA2 and what algorithm it uses?
Yes, sir. WPA2 it's a third type of security. It uses the AES algorithm, advanced advanced encryption scheme, and it's it's a secured and no one is able to break it till 2018, and it's a CCMP, and it's a CCMP encryption, and it's the most secured. And the WPA3 is also the AES GCMP algorithm. It uses the Galois counter mode protocol, and it's a most secure till now.
Yeah, that is correct. And the full form of WPA is Wi-Fi protected access.
Wi-Fi protected. Okay.
Okay.
Yeah.
So WPA2 use the AES CCMP, and the PA3 is AES GCMP. Okay. All right, guys. I'm gonna stop the recording. Any questions, guys?
Sir,